so much. I hope that I will be visible for you. I suppose I am. But also for you. I'm pointing to the screen. I don't know how well that works, but yeah, good. Okay, cool. Oh yes, you're over there. Okay, so thanks so much for having me. I'm really excited to be, well, I want to say back here. I've been here numerous times, going back to when I was visiting in 2003 or something like that, or 2. So to find Colin Housen here, and also Richard Bradley, and so on. And so I'm very glad that I get this opportunity to present to you about something that has been with me ever since then. Yeah, so I am going to present stuff that somehow will be weaved into a book that I'm writing on the foundations of statistics. And that book has numerous themes, too many, that's why it's not finished yet. But one of them is statistical evidence. And so that's what I'll be doing now. You probably know this quote, Mark Twain. Lies, damned lies, that's a different type of lie. And statistics, another type of lie. This quote is so overused, but I'm using it as well because I think it hammers something home that everyone needs to know. Namely, that statistics are malleable. Statistical results depend on numerous theoretical starting points. So, of course, a statistical model needs to be assumed. This is true in all approaches to statistics. In particular, and including the likelihoodist, or like Harold Jeffreys is a kind of founding father of that, the Jeffreysian way of doing statistics. But additionally, there are other ways in which theoretical starting points factor into how we do statistics. There is, and this is going to get a lot of attention in this talk, there is a dependence on the sample space. This is so in classical, or I like to call it Bernoullian. This is what Ian Hacking uses the term Bernoullian statistics. And famously, there is, for Bayesian inference, the Bayesian school of statistics, there's of course a dependence on the prior. So these are theoretical starting points that are necessary for us to do statistics. And what's also kind of known and sort of ambient and around us is understanding that these theoretical starting points somehow encode inductive assumptions that we're making. So by means of starting out with a statistical model, putting a prior over it, or saying something about experimental design and then saying something about the sample space and whatnot, in all of these ways, we get ready for doing an inductive inference. So that once we collect data, we know what to project and what to expect in the future. So these theoretical starting points have a role, namely, they encode inductive assumptions. And they're needed. We can't get away from that. It's inevitable. And what I'll be doing today is basically I'll pick up that theme, which I think is a theme that you can see throughout the history of statistics. That people try and sort of make as few inductive assumptions as possible, but they don't actually succeed, and in various ways we'll always have to come clean on that. Now I want to shift attention. This is still true, but I want to shift attention to something that I think is somewhat underappreciated in the foundations of statistics, and it is the item that we frame the observations, or the data. I'm going to use the word observations, but I could have used the word data as well. That's what's been given, the data. I'm going to focus attention on the way in which observations are framed to become evidence. I have a reason for that. So, I mean, the things I mentioned just now, they're mostly to do with the theoretical structure that is there, like the model and the prior and the sample space, and so theoretical structure. And that's all very well for statistics, but there's a new kid on the block, and it's called machine learning, or data-driven methods. And in the machine learning, most of that stuff, the model and the sample space, nobody talks about that. the seemingly only input for a machine learning method is data. So that if we have to try and find where those inductive assumptions are, we're led to go look into what the data are and how are those data conceived. So my reason to look at the framing of the observations as evidence is to do with the, well, this is for my project on machine learning and data science in psychiatry. This is a plot of how much that those terms show up in psychiatric research papers. And you can see it's a steep hill. Lots of use of machine learning. Yeah? So we need to, as philosophers of science, come to terms with what's going on there. And this is my attempt to make some of the insights from the foundations of statistics relevant also for that field. Right, so that's what I focus on, and here's what I am most concerned with. When I say, oh yeah, it's all relative to a theoretical starting point, and now we're going to try and find what those theoretical starting points are when we turn attention to the framing of the observations to turn them into evidence. I'm kind of entirely buying into this idea that, yeah, statistics is relative, it's lies, or damned lies even. And that should worry us. Because, as you probably know if you've read a newspaper in the past few years, the authority of science is under attack. So we can't just go, oh yeah, sure, it's just whatever you make of it, Kellyanne Conway. If you think that there are more people at the inaugural lecture or the inauguration of Trump than there were at the inauguration of Obama, yeah, I mean, we have facts, but you have alternative facts. And this is Kellyanne Conway, who's the spokeswoman for Trump at that point. Well, I think that would be terrible. So we have to somehow acknowledge that there is this relativity of statistics and defend the objectivity of statistical science. So that's the sort of main concern I have here. Yeah? And I want to end with a kind of defense of a normative and a pragmatic empiricist basis for the objectivity of statistics. So that's where I'm aiming for. Yeah? Now, I'm not doing that for data science because I haven't gotten there. Yeah? But it's going to kind of play a role in the intermediate. Everyone there? This is the talk in short form. What it's about, where I want to go. So now I'm going to get more precise on it. So I want to start with warming up a bit by showing a certain context sensitivity that we're all familiar with. This is the choice group after all, so I thought it'd be nice to do a choice problem. So that's number one. And then I'll get into a couple of topics all to do with Bernoullian statistics. Yeah? So this is all classical statistics. And I'll show that that same idea of context sensitivity plays a role there. And that tells us something about the framing of observations as evidence. Then I hopefully will get to these two. I'm not sure. Because it depends on how verbose I will be. But I hope that I will be able to say two things about Bayes, one, and about sort of likelihoodism as well, on framing the observations as evidence. And then finally I get to this defense of a relativized objectivity. So that's the plan for the talk. Right. And as was announced, I'm quite happy to take questions. We're not that big a group. I'm also very happy to have debate. But at some point I'm going to then run over time, or I'm going to have to stop the debate. So let's see how we go. Here's your dinner to get started. So, this story is undoubtedly familiar to all of you. So you might be in a restaurant, yeah? And the restaurant is quite simple in its menu. It's either serving a salmon steak, or it's a salmon with pasta with salmon, or it's a vegetarian pasta. Yeah? And you like the salmon pasta. You think that's what you want. Yeah? Then the waiter comes along and tells you So to be clear, you're not interested in the salmon steak. You want the salmon pasta. Then the waiter comes along and tells you, oh, by the way, sorry, there's no salmon steak today. And then you go, oh, hang on, in that case, I want the vegetarian pasta. Is everyone with me? It's a violation of the independence of relevant alternatives. Can that be rational? Yeah, it's not that weird. You know, so let's try, but I'm not doing anything new here. I've checked this morning with Richard. So what happens there is we learn something about what the options are. When it turns out that one of the options, the one that you are actually not preferring, is taken out altogether. For instance, you know, you didn't want the salmon steak, but you were presuming it was fresh salmon, so that you love salmon. When the salmon is fresh, you like salmon pasta. But when it turns out there is no salmon steak, you're like, oh, hang on. So the cook can't even cook salmon steak because there is no such nice, juicy, fresh piece of salmon there. The only salmon that I'm going to get is the leftover salmon in my pasta. I don't want that. Yeah? So that's a simple story, but what really happens there, you might say, is an update of preferences. Yeah? But interestingly, the update was so it's by something that was first considered irrelevant, and then you learn something about it, and then afterwards sort of factors into what the other options, what the character of the other options is. Yeah? Now hold on to that thought, because that's going to play a major role. Yeah? So you could say, oh yeah, so you update because you get some more information from the fact that the salmon steak is out. We can also do this better, I think better, but it's sort of neither here nor there. You debate this. You can say, well, actually, your whole space of options was constructed wrong. You should have already factored in that the fresh and fresh and leftover salmon, those items should have been in your option space, and then you would have no violation of IIE would have occurred at all. Yeah, that's another way of doing it. I'm fine with that. Right, now let's move over to something that is closer to my home base, the foundations of statistics. So there's this principle in the foundations of statistics that you may have heard of called the likelihood principle. And the likelihood principle basically says something like, the evidential impact of an observation is entirely mediated by the likelihood of the hypotheses for that piece of, for that observation. So there is nothing else, nothing other than the likelihood of the hypothesis, so for that observation. So in other words, the probability on the assumption of that hypothesis for that particular observation. That's the only thing that matters to the evidential impact that that observation has. And whether there were other observations you could have made does not matter. That starts to sound like the IIE, like the independence of relevant alternatives. Stuff that sits in the context is not important. The only thing that matters is the likelihood. Yeah? So listen to this story. This is a really weird story. So let's say you're doing an experiment with a voltmeter, and you've been measuring, but you see the voltmeter only goes to, I think it's like, I don't know, like 30 or something volts. And that's fine because you measured and it was 20 and 21 and 18 or whatever. Yeah? So you're fine. Yeah? The statistician doing the analysis goes, oh well, on the basis of these results, yeah, well, you can only measure up to 30 volts. You never did, but you cannot have measured 40 or 50 volts because you used this dinky thing. So on this basis, you have a censored data collection, and so you cannot reject your null hypothesis. Then you go, what? No, wait. So no, we have another voltmeter. If we would have gone over 30 volts, we would have seen, and we would use the other voltmeter that's in the cupboard. It's fine. We can use it. Oh, says the statistician. Well, in that case, you could have measured over 30 volts, and so, yeah, then you can reject your null hypothesis. You go, what? This is strange. Okay, fine. Then next week, you try and use this thing. It turns out to be broken. And you call the statistician, from your lab, you go, well, it turns out the other voltmeter is broken. And they go, well, in that case, you can't publish because so how weird is that? That doesn't make any sense. You never measured anything over 25 volt, so this thing is fine. However, and I'll explain why in more detail in the next section, the way classical statistics works, the way Neyman-Pearson testing works, is such that the statistician is doing it right there. Yeah? It matters that you could not have observed over 30 volt, even though you never saw anything over 30 volt. What you did not but could have observed matters to what you actually did observe and the evidential impact of what you actually did observe. Okay? So that's the likelihood principle, and that's what is going on here, that there's some kind of peculiar context sensitivity or evidential impact or evidential value or evidential content in classical statistics. And I'm now going to try and unpack this. And keep in mind this idea of IIE. We're still there? Yeah? Then let's go. So this is a quick run of statistical testing. Statistical tests, you're familiar with this somewhat, like Neyman-Pearson statistical testing. A lot of social scientists, medical scientists, everyone does this. Yeah? So it's dependent on the statistical model, but also on the sample space. Yeah? Let me run through Neyman-Pearson testing very quickly, so that everyone is freshed up on it. And then you'll see how, in the next section, how violations of the likelihood principle might occur. Here we go. So, we test a null hypothesis. This is a hypothesis. Actually, a hypothesis is always a probability assignment over data. Yeah? And you always test it against an alternative. That's also a probability distribution over the data. Yeah? This thing here is called the likelihood ratio. It's just the probability of that piece of data S, yeah, according to the null, and then divided by the probability of that piece of data S according to the alternative. Yeah, that's the likelihood ratio. Now you can order all the samples according to this likelihood ratio, starting the lowest, going up to the highest. Yeah?
All the possible samples.
All
the possible samples.
Yeah, all the possible samples. All the ones that are possible, according to your preset sample space. Right. Now you draw up this so-called region of rejection you see in the Cairo function. You see, I include one sample out of the set of samples, possible samples. I include that in the region of rejection if the likelihood ratio is below a certain threshold. So these are all the samples that are really less probable according to the null hypothesis than they are according to the alternative, right? And this number is low, and all those low likelihood ratio samples S, yeah, they get assigned the number 1, and so they're included in the region of rejection. What's the procedure? We reject the null hypothesis, and so adopt the alternative, if the sample that we actually observe is included in the region. Is everyone with me here? It's fairly simple. I will illustrate it a bit if this goes too fast. This procedure is associated with error rates. Yeah, so you could say, actually the null hypothesis is true, so I should look at this probability assignment. And then let's see how often it happens that I still end in the region of rejection, and so reject this hypothesis that's actually true. That's my type 1 error, significance level. I could also be wrong in another way. That's beta, but I'm gonna... So I correctly reject the null, yeah? That's the power of the test. So actually the alternative is true. And so I look at when I reject the null, that's when I'm in the region R, according to what probability is given to that region by the alternative hypothesis. So this is the probability of correctly rejecting the null. Okay, that's the power of the test. And here's the nice fact. We want to, of course, maximize power or minimize the type 2 error and minimize the type 1 error, minimize significance. That's when we're doing best. Proof. You get there if you do a likelihood ratio test. So likelihood ratio tests are optimal. Marvelous. So you set yourself some kind of significance level, typically 5%, and then you do a likelihood ratio test, you're guaranteed to get the maximal power that you can ever get. Yeah, so that's a guarantee. That's what Nijman and Pearson tell you. Let me illustrate this, and then you can see why this leads immediately to violations of the likelihood principle. In itself, this does seem like this is just standard statistical theory, and it's what everyone uses. No hypothesis test, or Nijman, Pearson, no hypothesis testing. Here we go. So we're back in the restaurant, and now it works differently. You get a meal, and depending on what cook is in the kitchen, there's various probabilities for getting this or that meal. Anna, for instance, if she's in the kitchen, she never cooks a salmon steak. She very rarely cooks salmon pasta, 5% of the time, and almost always cooks a vegetarian pasta. Yeah? Ben, however, well, his distribution is differently. Yeah? So what I've done here is I've ordered already these 3 items in the sample space according to their, if you notice, I've ordered them according to their likelihood ratio. Yeah? So likelihood ratio of 0. 0 divided by 0.4. This is a likelihood ratio of 0.05 divided by 0.2. So that's a quarter. This is a likelihood ratio of 2.375. So these are the items in the sample space. Yeah? These are the likelihood ratios. So now we can do a test. What's the region of rejection? Well, we want the error rate, the type 1 error rate, to be 5%. So we include this one, this item, and this one as well. Because that adds up to 5%. So we reject that Anna is the cook with a 5% significance. If we get a salmon steak, that's impossible. So we know for sure that Anna didn't make it. Or if we get a salmon pasta, then yeah, she may have made it, but it happens only 5% of the time. Yeah? If Anna is actually the cook, that we then reject that she's the cook on the basis of the fact that we get a salmon pasta. That's how that works. Everyone there? Great. So that's how. So now, okay. So fine. This is the region of rejection. It's these 2. Yeah. Now things get tricky. Here's Mariana. She is also a cook in that restaurant. Mariana has this profile. She does sometimes cook salmon steak, 5% of the time. She also sometimes cooks salmon pasta, also 5% of the time. She mostly cooks veggies, much like Anna. Yeah? And Ben is the same as Ben. All right. Now what's the region of rejection? Anyone care to guess? I've ordered them according to the likelihood ratios. Where do you draw the line? You want 5% significance, so you're going to reject that Mariana is the cook when you see a salmon steak. That fills out the 5% error 1, type 1 error. So you're not including the salmon pasta in the region of rejection. Because then you would make a mistake of falsely rejecting Mariana 10% of the time. That's too much. You want a 5% significance. Yeah? All good? You really shouldn't be shy if you think like, wait, this is important that you get this. So, okay. So, what do we know now? Once we get the salmon pasta, what do? Do we reject that Mariana is the cook? No, she could still be the cook. Right? According to this procedure. However, let's look at the likelihoods. The likelihood for getting a salmon pasta with Mariana in comparison to Ben is just 0.05 against 0.2. For Anna, it's 0.05 against 0.2. Why is the hypothesis of Anna being the cook treated differently if we find the salmon pasta to the hypothesis of Mariana being the cook if we get a salmon pasta? Why? Not because of the likelihoods, because they're the same. So there's something else that causes it to be the result of the procedure that if we get a salmon pasta, we do reject that Anna is the cook, and we don't reject that Mariana is the cook. What is different? Well, Mariana, already, with the hypothesis of Mariana, it's already possible that you get a salmon steak. There's a 5% probability of getting a salmon steak, and so that's part of the region of rejection, and it fills it out. Yeah? And so because it could have happened if Mariana were the cook, that you got a salmon steak, because that could have happened, you don't reject that Mariana is the cook when you get your salmon pasta. And let's go through this very slowly. So why is Mariana's hypothesis not rejected? Because according to the hypothesis of Mariana being the cook, there is a positive probability to something that does not happen. What? So this is really weird. This is completely wrong. So you don't reject the hypothesis of Mariana being the cook because that hypothesis gives a positive probability to stuff that did not happen, that you did not see. You do reject Anna as the potential cook when seeing the salmon steak because in Anna's case, the hypothesis of Anna gives a 0 probability to something that did not happen. That should actually be better. Everyone there? This is how weird Nijman-Pearson testing is. It violates the principle of the likelihood principle. It violates that you only ever look at the probabilities of what you actually see, conditional on the hypothesis that you're considering. It violates that, and it does so in a weird way. It's sort of, yeah.
So why should it be better?
Well, Anna at least gets it right that there's no salmon steak. Because she gives that a 0 probability, and that's sort of better than the Mariana hypothesis gives a positive probability to something that did not happen. So this is Jeffries talking in a different context, saying a hypothesis may be rejected because it fails to predict an outcome that does not occur. That's the Anna hypothesis.
Isn't the whole point that you must have an alpha of 5%? So in order to have an alpha of 5%, this has to be the consequence.
Yeah, this example is of course cooked up for the only purpose of illustrating that this is a problem, that you get violations of the likelihood principle. However, the point of the violation of the likelihood principle generalizes. So if you say, yeah, but that's because of some, you fix on a certain significance level, no, it happens all the time. So also if you take any other significance level and you look at examples where that flexibility actually has some import or changes the situation and change, you can always come out at violations of the likelihood principle. It's not, yeah. So it's a fair question, but yeah, the answer is that actually doesn't help you, that you have flexibility in choosing your alpha and your beta. Yeah. Are you happy enough to go on? Because your question is right. I mean, what is exactly... So the weirdness here is that a hypothesis, is not rejected, but in virtue of the fact that it gives a positive probability to something that never actually occurred, namely this salmon steak, and that is a peculiar situation. Yeah. Okay. Now that I've gone through all this, I can conclude this. We violate the likelihood principle. The results depend not just only on what we did observe, but on what we could have observed and did not. Yeah? Somehow in the procedure it matters what Mariana and Anna as hypotheses say about stuff that does not happen. About that salmon steak, for instance. Yeah? So, okay. I hope that this sounds to you like a violation of the independence of relevant alternatives. Somehow stuff that is irrelevant factors in anyway. Yeah.
Just wondering what would have happened if we had lumped together the alternative options into one option. Would that change anything?
Very nice question, I'll get back to it. Because yeah, that matters. That is actually in a way a solution to this issue. Can we make sense? So the question now is, what happens here, and can we sort of, inspired by the story about the independence of relevant alternatives, we could now try and make sense of this too. We could say, yeah, sure, it's not so strange that the context matters. Just like, you know, the fact that the salmon steak was not available made me switch my preferences to the vegetarian pasta. So stuff that was irrelevant somehow factors into what I did consider. Yeah. Now I have the same sort of thing. The only thing I actually saw was the salmon pasta, but the significance or the meaning or the sort of the evidential content, the evidential value of that salmon pasta changes because of the context in which I'm considering it, because of the sample space in which I'm framing it. Yeah, and that's the leading idea here that I have. Okay, so let's think again. This is actually what I just said. So, you know, we can try and make sense of, much like we made sense of the independent alternatives violation, we can try and make sense of this violation in the same way. Somehow the salience of characteristics of the observations depends on the framing we provide for the observations. Here's a simple solution. Here we go. Well, we can just say with coarse grain, what do we actually see when we get a salmon pasta? Well, you could do this. You could say, well, you know, really, when you're comparing Anna to Ben, the only thing you're really looking at is if there's salmon there. Because that's sort of the distinguishing thing. There could be salmon for Anna, but it's a 5% possibility. Yeah, and so that's the sort of salient feature about what I see. So what I'm really doing with my procedure, and of course it's all stylized, but I generalize out to like the whole edifice of Nijman Pearson. What you're doing is you're kind of selecting out of the salient. That's why you get different results. Because in the case of Mariana, what is salient is not anymore is there salmon, but rather is it pasta. Yeah? There's the 5% possibility of no pasta. That's a salmon steak. And the rest is all pasta dishes. That's what you're expecting with Mariana. So one way of getting out of trouble is coarse graining your evidence. Or rather, let me be more precise there. Coarse graining your data, coarse graining the observations, so that in your coarse grained representations, they reflect the evidential structure. Because what is salient about some piece of data is what ultimately counts as the evidence. And here the evidence is the salmon, no salmon, and there the evidence is the no pasta versus pasta. So that's one way of getting out of it. However, we swap out one violation for another, because now we're violating total evidence. Yeah.
Just to trying to understand why this is a solution. Is the thought that if we frame it this way, then we reject the Anna hypothesis under just the same circumstances in which you reject the Mariana hypothesis. So there's no violation of the likelihood principle when we frame it this way.
Indeed.
But wouldn't the objection be that it's sufficient that we get a violation of the likelihood principle on one acceptable framing for the principle, for the problem to occur? So, Anna has this sort of thing with the dominance principle. I mean, you have these occasions when we don't get, when the principle seems okay, but the problem is that there are occasions in which it's not okay, and that's enough to... Anyway, so that's a... No, it's not clear to me this is a solution.
I'm with you on that, and actually, if I manage to get there, and I think I will, by skipping some stuff, I will try and say what we need for a better appreciation of statistical evidence, namely more normative guidelines, more rationalization of how the framing is supposed to happen. Because indeed, just saying, oh, well, there's another framing in which this goes fine. It's not really enough until I can say something like, and that way of framing it is fitting for the situation and has a kind of normative backbone, or follows a certain guideline. Once I'm there, I can maybe say, and so there is no real worry left. But I'm with you that needs to be there. Yeah.
It's possible that what you just said indicates you're going to get to this, but I would have thought of the principle of total evidence as being like relative to a framing. Like having structured how I want to see the observations this way, when forming my credence value, I have to take out all the things thus framed. And in that case, it's not obvious to me this doesn't involve a violation of total evidence.
Yeah, you're right. I think you're right. I think no. So there is a sort of primitive understanding of this principle of total evidence, where you say, well, there is of course a fact. The facts, and then you just go, I don't know, like Arthur Fine, you just bang the table or something. But then, so of course that's the total evidence or something like that. But I'm actually moving towards an appreciation of the philosophical point that there are no. I mean, notice that I am fearful of Kellyanne Conway and her band, and I will come back to that. But I think that is actually a mistake to think that there are facts, obviously, or something like that. And so your point of like, well, it's always relative to some kind of frame, and that frame is up to us. We need to choose that. And yeah, I agree with that. And that's also, but then we need guidelines for how to choose our framing, and we need some kind of story there.
That's very good.
Yeah.
Carnap died to save us from that fine nonsense.
I-
That's good stuff.
This is indeed, Carnap will be on the slide in a while. Of course, I can't give a talk without referring to Carnap. Here's another way of doing it that I kind of like, and you can play around. This is more in a sort of Bayesian reconstruction fashion, and I want to just quickly show this. There's a lot of stuff you can do here, and I've actually cut out quite a bit of sort of fancy footwork to play around with the conceptualizations. But here's a nice way of thinking. So let's say we're comparing Anna and Mariana. We can also say, well actually it's a two-stage process. You first, what do you get something on your table, and it's a salmon pasta, but you first look at the salmon. Like, look at salmon. And there's pasta underneath. So there's a sort of ordering to this, so that's and you get this kind of likelihood structure. And then you can notice this, that once you see the salmon, Anna is, Anna is, you're like, oh, that's so it's very, like, she takes a big hit, so the Anna hypothesis is kind of out. Mariana, not yet, it's at least, it's twice more probable still. And then you get the next stage, but you kind of, at that point you've lost interest because you know Anna is kind of out. And of course, something happens here. This is called restricted choice, and today it's funny because Richard and I were talking about this morning, so it's a bit like the Monty Hall dilemma. There is still an update step here, and so there's still some kind of impact. You see 50-50, so ultimately you end up with the same likelihoods for Anna and Mariana when it comes to the salmon pasta. But that second part of the update, people conveniently forget. This is another way of violating the total evidence principle. And one that sort of, I think, brings out how salience is worked into the story. The thing that is salient is the salmon, when you're comparing Anna and Mariana here. Yeah? So that's another way of looking at the situation. What I want to take away is, of course, the general point that you can repair violations of the likelihood principle by coarse graining or by reorganizing how you frame the observations. And that should teach us something. So maybe it's not, I mean, I think violating the likelihood principle can be really crazy. Like in this case, it was obviously a little crazy. But what is general, and what I think is something to take seriously, is that we are at the steering wheel when it comes to what the observations are telling us. And that is the case for Bayesians, and we know that's the case for Bayesians because we can subjectively choose all our likelihoods, and there's a prior that factors in, and all of that is somehow theoretical structure that mediates how the observations impact on our beliefs. And we choose that ourselves. So for Bayesians, we already know, we are at the steering wheel when it comes to the significance of our observations. I think for classical statistics, for Bernoullians, it's an important message that this holds for them too, and you see it in the violations of the likelihood principle, because in order to kind of navigate those violations of the likelihood principle, what you end up having to do is rethinking how you conceptualized the observations. And that is the signal that they're not more objective than the Bayesians, they're just subjective in a different way, is what I want to say there. Yeah? It's not a tu quoque kind of like sort of rhetorical trick towards the. I don't mind at all which school of statistics you use. It's just, really it's all fine, but you need to be aware of what it is. And so that's an important message for the Bernoullians here. Yeah. Right. So that's that completes one major part. I don't know how I'm doing on time. I'm doing terribly. I think I have another 10, 15 minutes left, or what? 10. Ooh. Okay. Well, I was already guessing I would not be able to do this. The quick takeaway message for the Bayesians is that the priors matter to how the observations impact on your beliefs. So yeah, what else is new? This is a cute example, and I love this example, and I'm happy to kind of over a beer talk about it. Yeah, this is a less well-known example. This is from Malcolm Forster. Did you notice if you have a scatter plot and you take the x dimension to be the exogenous variable, you get a regression line, let's say if x equals y. If you regress with y as the exogenous variable, as a sort of external variable, you get a different regression line. Weirdly. So what does that mean? Well, again, skipping to the... So this is a nice... And Forster took this to be a violation of the likelihood principle. It's not. Here's some calculations. The main thing is... yeah, I'm sorry. To explain what's happening there, because there's no magic here. It's just one simple probability assignment over two continuous variables. Yeah, it's like all of this is Gaussian distributions, and well, it just turns out framing one variable as exogenous has an impact on what the observations mean. It's also a framing choice. Yeah.
I think actually that's an important part of causal discovery, that they use that asymmetry to figure out what is the cause of what.
Yeah, good point. Indeed. So this is actually deployed. Yeah, yeah. So thanks. That's a nice point. Actually, yes, you picked it up. All right. Now, finally, to the my attempted defense of statistics, because up till this point, it's roughly like this: that what we see and what we conclude from it is determined by our own theoretical framework. Yeah? And now, does that mean we're in deep trouble and that we should just keep this? I mean, we're in this room, we can all keep it quiet. We don't have to tell anybody. But I think that would be a pity. For one, there's obviously a lot of things we can do. We can this is all part of that project, that book I'm trying to write. There is an underpinning that we can find for statistics in which we rely on at least effectivity, the sort of capacity to be true or false of statistical hypotheses, and the validity of the arguments or the validity of the reasoning patterns that we have in statistics. And that's an appeal to a kind of objectivity that we know from logic. So there are at least these two ways, by means of very specific ideas that you can develop on what a statistical hypothesis is and what an inference is and so on. There are ideas there to kind of beef up the objectivity of science in these two ways, in the effectivity and the validity of what statistics is about and how it reasons. But next to that, I think we should not run away from, this is, for those of you who like psychoanalysis, this is a sort of the part where we face ourselves. So, we have to accept that our best understanding of statistics shows it to be a relative affair, yeah? And what actually does that? Why is that such a big problem? Why is this objectivity such a sort of painful thing to give up? Yeah, and what do we replace it with? Should we give up objectivity or not? And I'm very serious about this. I mean, I've been joking a bit, but I'm very serious about this because it's not a joke. What happens if you look around at what happens with the foolishness of the world. And so there is this enlightenment ideal that I think we carry the torch of to some extent, where we need to do the science in order to help humanity forward in some way. And it's a value-laden affair, and it's everything to do with that we try and do that honestly, in a way that is open to democratic control, and that we do that rationally, according to principles that somehow hold up. So this is like a very serious affair. So I know it's big swollen words, but it is very serious. And how can we do that? Well, yeah.
Well, I mean, isn't this a place where theory-ladenness of observation actually kind of comes to the defense, right? Because what the problem you're showing is that, well, if you can flip back and forth between frames kind of at will, right, then of course you can end up getting these reversal effects, and then you don't really know what you're actually talking about. But if the normative commitment you want is, look, you fix to a theory in advance, you commit to a theory, that gives you the required framing that you have, so you don't actually have this arbitrary choice about how you actually classify observation, then that actually provides the conversational continuity across time.
Yeah.
So what seemed to be like a bug actually becomes a feature on this view.
Bear with me. I agree with you, I think. I do want to say we're not, so yes, this is the format, but now how do we execute fully is something I still want to talk about. But I'm with you that it is not a bug, but actually a benefit or virtue of statistics, that it has this. If we fully work it in there, we can make use of that, like by some kind of judo move where we. Yeah, so it is actually, I think I agree with you there. So before we make that leap, we go way back in time to just see this problem for what it is. It's a problem of induction, as always. You know, it's the problem that we don't. How do we learn from data? Yeah, well, by making inductive assumptions of some kind or other. Otherwise, there's nothing to learn, right? And so framing the observations as a certain kind of evidence is similarly, well, that's where we make the inductive assumptions. Yeah? We have, certainly in statistics, and this is very funny to look at, we have always tried, every school of statistics and every approach to statistics, again and again and again, tried somehow to rid ourselves of that way we have to have subjective starting points, yeah? That's the knee-jerk reaction. Diminish the subject-relative component. Don't. It's not working. This is the Kantian response that you lay out there. You say, no, it's because of the theoretical content that we can conclude anything interesting from the observations. So it's nice that there's theory-ladenness in the observations. It's nice that's a good thing. We do that ourselves. We frame the observation in a certain way, and thereby this is arguably the sort of Kantian idea that then gets worked into the logical empiricist. I mean, Reichenbach is missing, and so is Carnap, but I think he's next. This is Kuhn. This is Helen Longino. About Longino, I want to say more in a bit. I think all these people work in a broadly Kantian tradition, where they acknowledge that, yeah, it's our work to conceptualize so that we can do meaningful induction. Sure, let's get to work, let's do that work. That's the pragmatism. Yeah? This is not a coincidence, by the way, that this is also Brian Skirns' book, but yeah. So what we have to do here is we have to choose and improve the frame. We have to do that work. We have to find out what's the right frame. And if we do that well, then we facilitate that the observations help us to useful theory. Useful theory. True, false, I don't know, but useful. The statistician's job is really only to ensure that guiding by the observations happens in the right and sort of valid way. Yeah? So it's not a statistical job to come up with the right framing. That's what the whole of science is doing all the time, I think. At least one part of what science is doing. So this is not new at all. Everybody says this. This is Finetti, this is Carnap, this is Reinskerms, who is not dead. And something worth reading. No, seriously, like he's great. He's really, I think, one of the best around on hammering this point home. You have to be empiricist and pragmatist. Yeah, so we are. Of course, it's like it's conditional, it's contextual. Our statistical results, but this does not lead to relativism. Yeah, because we have to do the work. Pragmatically finding out what our framing should be, and that's the final slide. That's what we should be busy with. How do we conceptualize our data? So, I mean, don't get me wrong. I think that there are other ways of approaching the theory-ladenness of statistics by looking more at the models or by looking more at all of that. But in the time when we are seeing data science methods, machine learning methods, AI methods take over science, I think it's very wise to not get sort of stuck on looking at statistical model structures because they are not there in the machine learning. And what is there in the machine learning is just data conceptualizations. Preparing the data, stirring it, and stirring it again if you don't get the right answer. Yeah? That's where the work happens in machine learning. And so we have to give that attention and say, okay, what are good rationality criteria for conceptualizing our data? So to give you some examples, Rosa, a PhD student of mine, is looking very directly into that. In psychiatry, you get this thing called digital phenotyping, smartphone data, large amounts of data, trying to sort of model what an individual is and what that individual is doing in order to predict, a manic episode or a risk of suicide, and the list goes on. But wait, what is the conceptualization of that person right there? What variables are chosen? That's where the induction happens. After that, it's just a machine that cranks numbers, but that conceptualization is where the action is. And yeah, that's where we need to look. Helena Slanickova, another PhD student of mine, looks at the decision structuring and perspective taking in evidence-based policy. Similar effort to look at how is it conceptualized? How do we conceptualize our problem domain here? So I think that's a very worthwhile sort of activity to do. And I hope that I've convinced you of, and I see your questions, so maybe I can just say, thank you so much for the attention, and please question.